Hi, friends, and welcome back to another installment of The Science of Music. Today, we will define musical tone and understand what it is so that you can learn how to define and recognize what an amplitude, frequency, and hertz is on a graph. You know you have it when you can compare sound waves to our new definitions and recognize them on a graph. For today's class, all you will need is a piece of paper and a pencil or a pen. So we have a question on our screen, and I would like it if you would answer these questions. We're gonna take about 2 minutes to do this. So with our prior knowledge of frequencies, and if you don't have any prior knowledge, make sure you link back to the videos that we've watched previously. Do you think that frequencies are different if they will be different if they occur on different instruments? So if I play an A on a piano, would it be the same as playing an A on the flute? Um, and why or why not? So take a minute and answer this question. So in answer to this question, yes, they are the same frequency because they are the exact same note, just played on a different instrument. So if I played an A on the piano, it'll sound just the exact same as an A on my flute. Um, so we have to define musical tone, right? And there's a huge variety of musical instruments and sounds. As you already know with your experience with music, whether it be in your general music class, choir, band, or even just listening to music on the radio. Um, but even two instruments playing the exact same note can sound very different. Um, and that's just because of the instrument. So like if we were to play an A on the violin down here, it would sound completely different than playing an A on a trumpet. And it's just because the instrument themselves make a different sound. And this is because music instruments produce sound waves, which is a combination of different but related frequencies. So that's like known as this big science word, harmonics, which all mix together to create a distinct tone or voice of an instrument. So what do you think? With knowing all of that, what do you think the tone or voice to an instrument is? Take a minute to think about and write down your answer to this question. So my answer is the tone or voice of an instrument is similar to the vocal cords and how we sing and talk with our voice. The way an instrument talks is just like the way we as people talk and can vary from instrument and by musician. So we're going to have an example here. Okay? So I play the flute. So I have my flute right here with us. The flute is an instrument that has a particular tone or voice. The flute sounds something like. Um, and it has a distinct tone when I play the flute. So if I were to play the flute, it would sound like. But if somebody else would have played that exact same thing, it could have sounded a little bit different because it varies by the type of flute that we have. It also varies by the way that the person plays. Because each musician has their own tone and their own voice. So we're going to relate all of this back to frequencies, which if you haven't watched the past couple videos, please make sure you go back so that you understand everything that we're talking about. So the lowest frequency is usually dominant. So what does this mean? When you're listening to a bunch of music, so if you hear that as like the melody, but you hear the bass going like your ear will register the lower voice, the bass, before it recognizes the melody, because of the fact that the lower frequency is dominant. So that's what dominant means. And it's a combination of other harmonics providing the shape of the waveform. So basically what this means is if we look at this graph, this dominant part down here below the line is super important because that's what our ear registers first. And you can't really just have like a melody that's above it because you need to recognize the dominant that happened and the lower pitches that dominate. So if I were to play this graph, this is what it would sound like. That's kind of what that graph could sound like. So the piano and the trumpet contain different combinations of harmonics and therefore sound different to the guitar when they're all playing the same note. So with all of this, we can graph the way that instruments make wavelengths while they're playing. So if we take a look of this graph, right? This middle one. This is what's something that the middle graph could sound like. And then same thing with the graph right here. So all of these graphs have different sounds. But now what we're gonna do is we are going to play this graph right here. Okay? Hold on to your seats. And that's something similar. That's something like this graph could sound like. If we had to demonstrate based off of the flute what these graphs looks like. So what after listening to all the music that I just played you, which mind you, not a professional, what trends did you notice when we would look at these graphs, and how are these similar to when you hear pitches that mimic these graphs? So like an example, there's a high frequency in the bottom graph on the left side compared to the one on the top, because the pitch is higher. And the pitches are higher, which make this a closer frequency. So take a couple minutes to answer that question. Great job. So for homework tonight, I would like you to listen to one of your favorite songs, any song that you would like. And I would like you to draw out the sound wave to any part of the song. It has to be a minimum 15 seconds, though, so that you can get a long enough wavelength. So an example would be this graph right here. Let me move me. So this is the wavelength that I came up with. And I used the song Rumors by Fleetwood Mac, and I drew the entire song. But notice how at the end back here, and even a little bit in the beginning too, we have two wavelengths, and that's because the instrument, so the big black one is the vocals, and the lighter one is for the instrumental, and for the musicians, because the vocals tend to die out, whereas the musicians are still going. So I wanted to illustrate that. You totally don't have to, but if you would like to, you absolutely can. So please make sure you send all of your awesome sound waves to my email so I can check them out. And I cannot wait to see you guys on the next one.